Medals.
Hello, everyone. Good afternoon.
Good afternoon po.
Good afternoon, ma'am.
Good afternoon po.
Good afternoon po. Good afternoon.
Afternoon, ma'am.
Okay. Can you hear my voice?
Yes.
Is my voice?
Yes, ma'am.
Deria Chapi. Deria
Hindi
Chapi.
po. Hindi po.
Very good. Okay. Prior to the discussion, I hope you have read the lesson that we will discuss today. So we'll be discussing today the central dogma of molecular genetics. But before we go into the lesson proper, let me first check the attendance kasi meron bonus po. I will be giving points for those who are here until the end. So I will be giving points, added points to your summative test in this lesson, summative test for this lesson. Okay, so I will start with section Santol. Please say present once your name is called. Joshua, Abusejo, Anyosa.
Present. Present.
Very good. John Edward, Mark Kenneth, Bulanadi, Earl Joseph,
Present.
Earl
Present.
Delantar,
Present.
Andre Labro, Renz Lilia, Hans Lomar, Raydel Samson, Raydel, John Ray Traboco, John Ray, Princess Jane Abelia, Princess Jane, Kiera Adamas, Francine Alaya.
Present po.
Okay, thank you. Amos Hana, Hana Amos, Denise Apura, Denise, Josel Faye Banario, Josel Faye, Andrea Beato, Andrea, Miska Cepeda, Kiana Cecista, Kiana,
Present po.
Okay. Marian Dulfo. Marian. Cristil Factor. Pentes Denisa. Galupe Hyacinth. Galupe Hyacinth.
Present.
Okay, thank
Present.
you. Tricia Gapud.
Present,
Tricia.
ma'am.
Angel Garcia.
Present.
Angel. Angel Garcia. Liana Gura.
Present.
Hazel Hilaria. Shira Habuli.
Present.
Charnet Latoha.
Present.
Giselle Mendoza.
Present po.
Jahara Montes.
Present po.
Jazel Padilla.
Present.
Isaiah Pagayanan.
Present po.
Pan Allison. Pan Allison. Yeza Puno. Ninia Ramirez. Ninia. Cherise Rijang.
Present.
Grace Love Sabido. Grace Love.
Present. Present, ma'am.
Turla Ella.
Present po.
Okay.
Present.
So those who are not here, those who are not here. Joshua from Section Santol. Joshua, John Edward, Andre Labro, Renz Rudolph, Hans Lomar, Princess, Kera Adamas, Denise Apura, Banario, Josel, Beato Andrea, Miska Cepeda, Jazzy Doldolea, Dulfo Marian, Factor Cristel, Denisa Fuentes, Garcia Angel, Pan Allison, Puno Yeza, and Ramirez Nina. So there are actually so many of you, Section Santol, who are not here. So let's take Section Mango. Section Mango. Zion Apita. Zion,
Present
please say
po.
present.
Present.
Okay, thank you. Mark Araba.
Present.
Mark.
Present.
Chad Banaldilla.
Present.
Bantiles, John David. Bantiles. Justin Bihar.
Present.
Strobo Lens.
Present.
Go Dick. Go. Ernst Hardillo. Ernst Hardillo. Malinaw Eugenio. Anay ha, adi pa yung nasubmitin module, anay kalila. Okay, Justin Bihar, are you there?
Present.
Strobo Lens. Strobo.
Present.
Go Dick. Go. Hardillo. Ernst. Malinaw. Eugenio, the fourth. Christian Andre Marasigan.
Present.
Alexi, Nicole,
Present.
Jade Ogale, Jade,
Present.
Carl Vincent, Carl Vincent, Panis, Yeshel Cesar, San Emmanuel,
Present.
okay. Uy, Marie Vincent, Uy, Uy. Marie Vincent, are you there? Uy. Aberia, Erica,
Present po.
Lorraine Abobo, Zoe Afable, Gail Alde,
Present po. Present po.
Zoe Afable, are you there? Zoe? Sorry, Django Afable. Gail, Ambil, Anna,
Present.
Raven Rose, Amoya, Raven Rose, Ampong Joyce, Apura Julia, Apura,
Present.
okay, Astakaan, Nash, Astakaan, Angeline Colima, Angeline, John Antoinette Dator,
Present.
Krishna de los Santos, Gislaine Jolola, Aliana Docena, Aliana, Jillian Gapate, Jillian Gapate, Julia Guevara, Julia, Lavado Antoinette, Lavado, Maxian, Maxian, Marasigan, how do you pronounce your name? So she's not around. Debbie Benson,
Present po, ma'am.
Peralta, Isabella,
Present, ma'am.
Promeda, Francesca, Promeda, Jaslyn Puno, Reese Sakmar, Reese, okay, Angelique Suwal, Angel Monroy. So section Mango who are not around during the attendance. Vantiles, Go, Hartillo, Panis, Seso. Uy, are you there? Uy, Marie Vincent. So Uy is not around. Okay, Abobo Lorraine is not here. Amoyo Raven, are you there? Ampong, Astakaan, De Los Santos, Gapate. Gapate is still joining. Okay. Marasigan, Promeda, Francesca. Promeda, are you there? Okay. Puno, Jeslyn, Suwal, Angelique, are you there? Angel Monroy, are you there? Okay. So I will be calling to check the attendance. I will be calling you during the discussion, just to check the attendance. Anyway, when your name is called, please turn on the microphone and answer what is asked of you. Okay, so as what I said just a while ago, we'll be discussing today the central dogma of molecular genetics. Actually, this is still a part of Module 4. This is still a part of Module 4. So in Lesson 1, we actually discussed the nucleic acids, the genetic material actually, which are kumbaga they are the starring, the actresses, the main star or the main stars in the movie. Okay, so the nucleic acids, the DNA and the RNA. So last time, if you still remember, we differentiated in terms of structure and composition, and not just the structure and the composition, but we also discussed the difference based on or in terms of the functions as well. Okay, so DNA and RNA are genetic materials that vary in so many ways, but they have so many things in common. Anyway, so lesson 2, the central dogma of molecular genetics, is a continuation of what we discussed last time. Okay, so after going through this module, you are expected to describe DNA replication, state the central dogma of molecular biology, describe the processes involved in the central dogma, and explain the role of DNA and RNA in protein synthesis. So this will be our guide in today's discussion. Okay, for a short recap, DNA stands for deoxyribonucleic acid. DNA, actually DNA, the acronym is more familiar than its meaning. Okay, so the DNA is basically made up of subunits, which we call as nucleotides, which is basically made up of a phosphate group, a pentose sugar, which is a 5-carbon sugar, and a nitrogenous base. So all of these 3 elements or 3 substances comprise what we call a nucleotide. Again, DNA is basically made up of so many nucleotides that are being joined together. Okay. So DNA, so we have here the illustration of the DNA where the phosphate group is attached to the pentose sugar through the 5 or in the 5-carbon. In the 5-carbon of the pentose sugar, whereas the nitrogen base is attached to the carbon sugar through, or to the pentose sugar through the 1st carbon. Although there are 4 nitrogen bases, only one of these 4 is attached to the pentose sugar. Okay, now. So what we call these actually these three substances that are joined together as a nucleotide. Pero if there is only a base and a sugar, we call it as a nucleoside. Again, please take this down. Kung itaadala nucleotide and a pentose sugar, we call it as a nucleoside. Hello, are you still there?
Yes.
Okay.
Yes, ma'am.
Okay, thank you. Again, basta duha lahira ha, pentose sugar and nitrogen base. It can either be an adenine, a guanine, a cytosine, or a thymine. We call it as a nucleoside, S-I-D-E, nucleoside. Pero if there is a phosphate group attached to the pentose sugar and a nitrogen base, then we call it as a nucleotide. Okay, hope you were able to get the difference. Okay, next. Okay, so this is the pentose sugar, which we discussed last time. So it is numbered. The carbons are numbered clockwise. So this is the 1st carbon, where the base is attached to the 2nd carbon, where the hydroxyl is attached to. In the case of a DNA molecule, only hydrogen is attached to the carbon sugar, to the 2nd carbon. So for the C3, attached here is the next pentose. Pentose, the next phosphate or the next nucleotide or the phosphate group of the next nucleotide. Kung katapusan hiya, attached to the carbon 3 is the hydroxyl group. So this is the carbon 4 and the carbon 5 where the phosphate group is attached to. Okay, now the DNA, the two strands of a DNA molecule. So as what I've said last time, DNA is antiparallel to each other and it runs in the opposite direction. Okay, so this is the 5 prime. Kung itong una, kung itong una itong usang strand, it starts with the 5 prime on the opposite strand. It is a 3 prime end. Didi 5 prime end. Didi naman, it opposite to that is the 3 prime end. So kung a 5 prime end, it starts with the pentose sugar. The pentose group rather, pentose group. Whereas on the opposite strand, it aaniha end is a hydroxyl group. Okay, so didi naman ha end, if it ends with 3 prime hydroxyl group, didi naman ha opposite, it will the substance found here is the phosphate group. So exactly opposite each other. Okay, so as what I have said, the strands are anti-parallel. One strand of DNA goes from 5 prime to 3 prime. So from 5 prime, okay, look at this one. So from 5 prime to 3 prime, and the other strand is opposite in direction. It goes through 3 prime to 5 prime. So from 5 to 3, from 5 to 3 downwards, and then naman from 5 to 3 upward. Okay, for the nitrogenous bases, this was a part of our discussion last time. So the nitrogenous bases are the purines and pyrimidines, where purines have double rings in the adenine and guanine substances, whereas in pyrimidines, there is but a single ring only in thymine and cytosine. Okay, now in the DNA strand, purine is connected to a pyrimidine and vice versa. So if it is a pyrimidine, then complementing to the pyrimidine is a purine substance or a purine base. Okay, so we go to the base pairings. That's what I've said. Purines only pair with pyrimidines, meaning adenine will pair only with thymine and thymine with adenine. Guanine will pair only with cytosine and cytosine with guanine. Again, in the complementary base pairing, adenine, which is a purine, will pair only with thymine, which is a pyrimidine. Guanine will pair, which is a purine, will pair only with cytosine, which is a pyrimidine. So that is the rule. That is the complementary base pairing rule. A with T, T with A. G with C, C with G. Please always remember that. Okay. Okay, so 2 hydrogen bonds are required to bond adenine and thymine. 2 hydrogen bonds are required to bond adenine and thymine. What about guanine and cytosine? How many hydrogen bonds will bind them together? Anybody? Anybody? 3, very good. 3. So 3. 2 hydrogen bonds for adenine and thymine. 3 hydrogen bonds for guanine and cytosine. Thank you for that. Question. Diba? Adenine is paired only with thymine, guanine with cytosine. If there is 30% adenine, how much cytosine is present? Sige daw, esep. If there is 30% adenine, so didakunuhan in a segment of a DNA molecule, there is 30% adenine. So if there is 30% adenine, then how much cytosine is there?
20?
20%.
20? Why 20? Why 20?
Adenine will be paired up with thymine. So 40% is left. And cytosine
then?
will be paired up with thymine.
And the answer is correct. Okay, were you able to get it? Who answered that? Please identify yourself. Who answered that? Who explained that? Hino pa daw adto? Pwede ako nakita didi. Okay. Okay. So hino pa daw adto nga nag-answer? Were you able to? Okay, thank you for that. Was that you, Alexi? Was that you explained, Alexi? Was that you?
Yes.
Okay, thank you for that. Ang galing talaga ni Alexi. So were you able to get the explanation of Alexi? Nakuha niyo? Ano yung explanation? Nasugad kasi iton hiya. 30% ang adenine. Ano? So A, 30% po, no? Opposite to adenine is thymine. So kung 30% ang thymine and adenine, of course, kay magpadis man hira, thymine will also be 30%. Ano? So pareha sira 30%. Kay magpadis nga hira. Adenine is paired with thymine and vice versa. Now 30 plus 30 is 60. 60 hiya. So 100 minus 60 pera. 100 minus 60 is how much?
40.
How much? 40. Very good. So 40% na laan bilin. So ini nga 40% pagtutungaon hit guanine and cytosine. So 1/2 of 40 is 20. For guanine and 20 for cytosine. So the answer is 20. Nakuha? Nakuha niyo?
Yes, ma'am.
Yes, ma'am.
Okay. So please expect similar question during the summative test. Next. Okay, so set here an explanation. Okay, adenine 30, guanine 20. Therefore, 60%, 80, and 40% CG. So, ini nga 40% pagtutungaon 20-20, that makes 40. 30-30, that makes 60. 60 plus 40 is 100%. Okay, so are you ready for the central dogma of molecular genetics? Are you ready?
Yes, po.
Yes, ma'am.
Okay, thank you.
Yes.
So the central dogma is actually, I'll give you an overview of the central dogma of molecular genetics. So itong concept, itong central dogma is actually, please take this down. It is the flow or the direction of the flow of the genetic information from DNA to the ribosome. The direction of, so the central dogma of molecular genetics is actually the direction of the flow of genetic information from the DNA in the nucleus to the ribosome in the cytoplasm. The direction of the flow, the direction tipakain, not tipakain. So the direction of the flow of genetic information from DNA in the nucleus to the ribosome in the cytoplasm. Okay. Now, in the central dogma molecular genetics, we will be discussing 3 very important processes. 3 very important processes. And these important processes are actually ways on how genetic material or genetic information is transferred. Okay, so we'll be discussing today. The 3 general transfers of genetic information. One is replication, another is transcription, and the last one is translation. Replication, transcription, translation. So didahan central dogma. Okay, ano kita ha? Central dogma. It's on molecular biology. It is simply the flow of genetic information from DNA to RNA, or from DNA in the nucleus to the RNA in the ribosomes. Dahil itong genetic, dahil itong central dogma, we'll be discussing how DNA is replicated, how the genetic information is transferred, and how the message in the DNA is translated into proteins, or how the language of the DNA is translated into the language of protein. Okay? Anay, nabasa lang yung messages. Na-ask permission po Chad, napasudlon. Thank you po. Naka din ang matasulod Chad kanina. Let me... po Chad. Anay, here. Okay. Okay. Ma'am, waray ko po binabate. By the way, nabate na ka mo? Nababatek niyo?
Yes, ma'am.
Yes po.
Kaya di man didiin. Waray ko no, niya binabate anyway. So, mahina itira signal dito. Basta, siya alak na yung handa ka mo nabate. Anyway, so, of the 3 general transfers of genetic information, we will start with replication. Okay. Replication. So as in itong main the main concepts in the central dogma: replication, transcription, and translation, or replication and protein synthesis. Okay, so we'll start with DNA replication. Let me ask you, where does DNA replication happen? Where does it happen, or where does it occur? Class, main pa daw. Main pa daw tiyan na hinanabo.
Nucleus.
Nucleus.
The cytoplasm.
Cytoplasm, another guess. In what part of the cell cycle?
Synthesis.
Space.
In very good. In the
Synthesis.
synthesis of interface. synthesis of interphase. So there is but only one major event in synthesis, and that is DNA replication. Now, DNA replication is very important. It is very important actually, and it must happen before the cell divides. Now, since you already have an overview or an idea of DNA replication, why is DNA replication important before the cell divides? Why must it happen before the cell divides? The fourth, malinaw. Kaya ano nga dapat mahinabo itong DNA replication before cell division? Kaya nga dapat hiya mahinabo. Dapat mahinanabuan na hiya before the cell divides. During after cell division, magre-replicate itong DNA. No, it doesn't happen. Replication must come first before cell division. Before mitosis or before meiosis. Kaya ano nga, dapat mahiuna itong DNA replication.
So the
Para
daughter cells have the same
makapag-
amount of DNA?
Okay, very good. Who answered that one? Para magkamay-ada ko no, the same amount of DNA in the daughter cells. Okay, who answered that one? Please identify. Who answered that one? Alexi. Okay. Thank you, Alexi. Okay, so okay. Replication facts. DNA has to be copied before a cell divides. DNA is copied during the S or synthesis phase or interphase, and new cells will need identical DNA strands. This is now the product of replication. It is because of replication that the two daughter cells or the new cells or the two new cells will have an identical DNA strand. Okay. Okay. Synthesis phase happens during interphase of the cell cycle. And it happens in the nucleus of the eukaryotes. The nucleus of the eukaryotes. In the case of prokaryotic cells, where does synthesis phase happen? In the nucleoid, dugtong nucleoid, ano't dugtong class? Nucleoid region or in the nucleoid. Okay. So DNA, in DNA replication, it begins at origins of replication. So DNA doesn't happen just anywhere. No, it begins at origins of replication. This is actually the site where replication should start. Itawag ito niya nga site is origin of replication. In the case of a eukaryotic cell, where DNA is quite long, there are so many origins of replication. Meaning to say, kay damo man itong origins of replication, all of these origins of replication do replication at the same time. Magdududrungan itira. para madagmit itong replication, para madagmit itong pag-replicate itong DNA, what God did is He made so many sites. He made so many origins where replication should start. Are you still there?
Yes.
Yes po, ma'am.
Okay, tumatila ka mo and take down notes, ha? Don't forget take down notes. Now, okay. Now, the origin of replication. When replication starts, this origin of replication will then become the replication fork. Kung inihiya an origin of replication, mabuka iton hiya and will become the replication fork. So it will form a Y-shaped region. Magbubulag iton hiya. Okay, so in this site, magbubulag iton hiya, and the origin of replication will then become the replication fork. Kay damo man hiya nga origins of replication, so damo hiya nga replication forks. It is in the replication fork where new strands will be synthesized or new strands will be made. Okay? Okay. Replication is a process. DNA replication is a process. And it entails a number of steps. So we have here 5 steps of DNA replication. First is the unwinding of the complementary strand. So meron nga ni unwinding, pag-open, pag-unwind, pag-open, itong complementary strand. Di ba ini nga duduha nga strands that are complementary to each other? Do you agree with me? Are they complementary to each other, class? Are the two strands complement each other? The answer is yes. So kung dinhi may ada niya. Kung dinhi may ada niya A, adenine. So what will complement with adenine? What will complement? Thymine. Very good. So kung dinhi may ada niya cytosine, what will complement with cytosine? Guanine. In other words, these two strands complement to each other. So they are complementary strands. Complementary strands. Tawag ha? Complementary strands. Because the nucleotides complement with each other. Okay, so the first step of DNA replication is unwinding of the complementary strands. So mag-unwind, ma-open up iton hiya. Next step is priming of the templates formed. Priming of the templates formed. Let me give you an overview to this step. So, di ba, mas nasugad kanina. Ha? Sugad. Ade. Okay, di ba ma-unwind na hiya? So, priming of the templates form. Pag unwind ito niya, pag open ito niya, the two strands will become templates in the making of the new strand. So, meron nga ni template, ano pa daw? Template. What comes into your mind? Ini yung magiging template ko, no? Itong paghimo, itong bago nga strand. Di ba, nag-open na hiya? Ini ko no hiya, nga complementary strands, magiging template in the making of the new strands. So, sumerin nga ni template, ano pa daw? Template, magiging guide hiya hiton paghimo, hiton bag-o nga strand, which we will discuss later. Okay, so the second step is the priming of the templates formed. Number 3 is elongation of the complementary strands. Fourth step is excision of the RNA, excision of the RNA primers and the replacement with DNA. So meron nga ni excision from the word excise. To excise means to paano pag-excise, class? Pag-remove. So excision of the RNA primers and the replacement with DNA. Remember, itong ginhihi mo din DNA replication. So there is no place for RNA nucleotides. So itong bubuhaton hiton cell, kukuhaon iton niya, it will excise or it will remove RNA nucleotides and will then be replaced with DNA nucleotides. So that is the fourth step. And the last step is sealing of the breaks or sealing of the gaps. So kung may ada din mga putol-putol, may ada mga putol-putol nga segment hiton ginhihimo nga DNA, then that break or that gap will be sealed para continuous iton DNA strand. Okay? Nakuha niyo? Nakuha niyo, class? Anyway, so gintagan tala ka mo overview. We will explain each step. Now, in DNA replication, since this is a process, for the process to become successful, for the process to pass through, enzymes are needed. So in step number 1, enzymes are needed para mahimo, ma-realize inihiya nga step. So with number 2, number 3, number 4, and number 5. Okay? So the whole process of DNA replication, to give you an overview of the process. So the whole DNA replication needs a number of enzymes. It needs a number of enzymes. Okay, let's take the first one. Enzyme helicase unwinds and separates the two DNA strands by breaking the weak hydrogen bonds. Di ba itong DNA, they are joined together. Inihira, nakita ka mo ini. They are joined together by hydrogen bonds. Diba? Do you agree with me?
Yes,
The two strands of a DNA molecule are joined together by hydrogen bonds. Now, how can replication become possible kung inihiya nga hydrogen bonds dire matanggal? Okay? How can replication fork be made kung inihiya nga duduhang nga strands nagdudugtong pa? So what God did is He created the enzyme helicase that unwinds and separates the DNA strands. Itong gamit naman hininga enzyme helicase, it will break the hydrogen bonds. Pag break itong hydrogen bonds, then the DNA strands will then be separated. Magbubulag hira. Kay ano? Nag-disintegrate na ang hydrogen bond, so there is no substance now that joins them together. natunaw na, nagkuan na hiya, ano pa daw, na-dissolve or na-disintegrate. So iton mahinanabo, dinhi, hanging na iton mga nucleotides. So meron na adenine, nagbulag na ang adenine and thymine. Walang forever talaga, class. Cytosine and guanine, nagbulag na hira. Guanine and cytosine, thymine and adenine. Kay ano nga nagbulag hira? Because of the enzyme helicase. Okay, siya ang culprit. Kay ano nga nagbulag ang adenine and thymine, guanine with cytosine. It was able to break down, or it was able to disintegrate this enzyme. It was able to break down or to disintegrate the hydrogen bond. Now, let's go back. Adenine and thymine are strongly attracted to each other. Guanine and cytosine are likewise strongly attracted to each other. Makusog ito nira attraction. Adenine with thymine, guanine with cytosine. So, kung waray buhaton itong cell, adenine will bind with thymine, guanine will bind again with cytosine. Okay? Kukuha niyo. Hira kayo magkuhan, hira kayo. Kung baga mag-partner talaga, hira. So makusog ang hira attraction. So dapat may buhaton itong cell. Okay? Ano't bubuhaton itong cell? It will make an enzyme, or it will help or it will seek the help of an enzyme, the single-strand binding proteins, to keep the two DNA strands separated and untwisted. Okay. So para padayon hira nga magbulag, okay, an enzyme called the SSB proteins, SSB. So the enzyme SSB proteins, or the enzyme the single-strand binding proteins, will keep the two strands apart. It will keep the two strands separated. Okay, di ba? Nasa na kanina, an A is strongly attracted with thymine, guanine with cytosine. So, para diri na hira magkabalikan, enzyme SSB protein, or the enzyme SSB, the single-strand binding protein, hihirugan ito niya para itong adenine will not join again with thymine and vice versa. Guanine will not join again with cytosine and vice versa. Okay? So here, the role of the SSB protein is to change, or there will be a slight change in the composition of the adenine and thymine para dire na hira magkabalikan. Kay kung parehas lagi hapon iton era composition, adenine will bind with thymine. Magkakabalikan at magkakabalikan pa rin sila. Okay? So, next. Were you able to get it?
Yes, ma'am.
Yes, ma'am.
Yes.
Okay. Again, the enzyme helicase, we're still in the nakita ng step. Unwinding. First step pa lang tayo, ha? Unwinding of the complementary strand. Okay. Nandito pa lang tayo sa unwinding. Pagbulag ang two strands. Two complementary strands, the unwinding. So there are two enzymes involved in the first step. The first one is The first one is actually three. The first one is the enzyme helicase. Another is what's this? The SSB proteins. And the third one is, salay, susurat ko na lang ha. The DNA gyrase. DNA gyrase or DNA gyrase or the enzyme gyrase or the enzyme gyrase. I don't know how to pronounce it. Anyway, so ano't gamit niya? Remember that DNA is twisted. Diba nasugad hiya? Twisted hiya. Ig-unwind nga ni inihiya, it iya hitsura, masugad. Sugad, dirya straight. Now, to get rid of this, para hiya ma-straighten, tapos maging easy iton replication, DNA gyrase must take its role. It will release the twisting or the twisted tension of the strands. I-straighten ito niya para maging masayon itong replication. Okay? Okay, so 3 enzymes involved in the first step. So one is helicase, SSB, proteins, and gyrase. Okay. Are you taking down notes, class?
Yes, ma'am.
Yes,
Ma'am.
Yes,
So
ma'am.
we go to the second step. We go to the second step. Now, who will give me the second step? Who will give me the second step of DNA replication?
Priming the
What is the second step? May ada naka-on iton phone. Please turn it off muna. Please turn the microphone off unless you are allowed to speak. Okay, so the second step is priming. Priming
the template.
Priming of the templates form. Diba? Nakahimo na yan template. Na kung sa rin kanina, sumira nga ni template, inihiya, diba? Inihiya, nagbulag na ano. So, inihiya nga, duduha nga strands will become templates in the making of the new strand. Template in the making of the new strand. Meaning, inihiya, magiging guide iton paghimo hanbag o nga strands. Example. Kunta ini, inihiya magiging guide niya iton paghimo iton bag-o nga strand. Di naman, magiging guide ini niya in paghimo hanbag o nga strand. Can you get me? Okay?
Yes, ma'am. Yes.
Okay. Now, so the second step is priming of the templates form. Priming of the templates form. So magtitikam na. Magtitikam na kita. Okay. Before new DNA strands can form, there must be RNA primers present to start the addition of new nucleotides. Now, class, masaring ka. Ma'am, kay ano nga? May ada RNA when in fact, we are making an exact, the cell is making an exact copy of DNA. Kay ano nga may ada RNA nga aada. Now, there is but only one substance that is responsible for the priming of the template, and that is RNA polymerase. Please take this down. RNA polymerase, or we also call them as RNA primase. RNA primase. Ano? So, inihiyang RNA primase, kasi itong direction kasi, itong direction, itong direction, didi kita. Itong direction, paghimo itong bagong nga template, paghimo itong bagong nga strand is from 5' to 3'. 5' to 3'. Now, ano it-aanhit ang 5'? Ano nga substance? Itadat 5' class. I think I mentioned this last time. Ano aanhit itong 5'? Pentose? Another guess. Phosphate, very good. Phosphate. Ano't aanhi itong 3'?
Hydroxyl group.
Hydroxyl, very good. Hydroxyl. Now, itong RNA, asyala itong may ada hydroxyl group. Asyala hiya itong may ada hydroxyl group dito 3 carbon. Ano? That's not 3 carbon. Anyway, so hiya itong may ada capability to start the replication process. Kasi itong RNA, adi na kita dito. Okay. So itong kinahanglan mo ko ang picture. Ay ha. Anay ha. Okay. So it is the RNA. The RNA actually has the capacity to synthesize hydroxyl group. Iya itong may kapas paghimo or pag-synthesize hydroxyl group, the RNA polymerase, or what we call as the RNA primates. So hiya itong maghihimo hin hydroxyl group. Takay kailangan hin hydroxyl group dida itong 3' end. Okay. Since RNA ito not take charge in the priming, so it will then synthesize RNA nucleotides. Ano? Okay. Balik kita. Okay. Itong dalagan again, the direction of the flow is, the direction of the making of the strand is from 5' to 3'. Dida itong 3', it aada nga nag-uuna is hydroxyl group. And the only enzyme that can make hydroxyl is RNA enzyme, or RNA polymerase, or what we call as the RNA primase. Now, kay RNA enzyme man itong aada or RNA polymerase, which is an enzyme, mag-synthesize nga iyahin nucleotides. Of course, it will synthesize RNA nucleotides. Let me ask you, Hyacinth, are you there? Hyacinth? Now,
Yes, ma'am.
please give me the RNA nucleotides. Give me the RNA nucleotides. Kung ang DNA nucleotides, we have Adenine, thymine, guanine, cytosine. What about the RNA nucleotides? So give me the RNA nucleotides. Hyacinth. Andre Marasigan. Andre Marasigan. Gapud Tricia. Somebody is raising their hand. Who are they? Sala. Yes. Zoe. Zoe. So give me the RNA nucleotide, Zoe.
Adenine and
Adenine.
cytosine,
Yes.
guanine
And
uracil.
And uracil, very good. So we have adenine, uracil, guanine, and cytosine. So these are the RNA nucleotides. Now, kay hiya man iton aanhidin, kumbaga hiya iton hiya iton in charge, so it will then make or it will then synthesize RNA nucleotides. Okay, RNA nucleotides. Okay, now, kita ha. Okay. So maghihimuhiya, itong iya masisynthesize na nucleotides is then called as the primer. Primer. Okay. So sa merengani primer, they are the nucleotides or primers. They are the nucleotides synthesized by the RNA primase. Ano ang RNA primase? The RNA polymerase. Okay. So next step is elongation of the complementary strands. Elongation of the complementary strands. Okay. So before new strands can form, there must be RNA primers present to start the addition of new nucleotides. Primase, the enzyme that synthesizes. Oh my God. Primase is the enzyme that synthesizes the RNA primer. Okay. DNA polymerase can then add the new nucleotides. Okay. So nakahimo na yan primer. Pakahimuhin primer, the DNA polymerase will then take its role. Okay, so the DNA polymerase can only add nucleotides to the 3' end of the DNA. This causes the new strand to be built in a 5-to-3 direction. Okay, now, like RNA polymerase, DNA polymerase is also an enzyme. Kung itong RNA polymerase synthesizes RNA nucleotides, the DNA polymerase synthesizes DNA nucleotides, adenine, thymine, guanine, and cytosine. Punta ini ang primer. Nakita ka mo yun eh. May ada dida o. Nakahimo na yung primer, ano? Nakahimo na yan primer. So nakahimo na yan pirahoy ng mga nucleotides. After that, the DNA polymerase will now arrive, will now come, and will continue synthesizing DNA nucleotides. Iko-continue ito niya. So dinhi nga mga RNA nucleotides ma-continue paghimo in DNA this time, DNA nucleotides, and the one responsible for that is the DNA polymerase. DNA polymerase. Okay. That step is the elongation of the complementary strands. Elongation of the complementary strands. Okay. Okay. Okay, now. The leading strand is synthesized as a single strand from the point of origin toward the opening replication fork. Let me go back. Balik kita nga diha. Dinhi. Now. Diba, ma-open hiya. Itong direction, the direction of synthesis is, or the direction of replication is from 5 going to the 3 prime. 5 going to the 3 prime. So it goes in this direction. From 5 going. Okay. 5 to 3 ha. 5 to 3. Kung itong replication fork, it iya direction is from 5 to 3, okay la hadi. Synthesis of the nucleotides will become smooth. Ila. So, dungan kasi itong hira. Paghimo dinhi nucleotides, mahimuliwat dinhi on the opposite strand, mahimuliwat hiya new strand. Masynthesize liwat hiya mga nucleotides. Kaya lang magkakaproblema. Now, iton pag-abre hiton pag iton replication fork, pag open hiton strands going this way, di ba? Going this way. So adi hiya na follow itong direction itong replication fork. Kaya lang pag-abot nga di magkakaproblema kay ano? Itong direction itong paghimo itong bag-o nga strand is from 5 prime to 3 prime. It will go against the direction of the replication fork. Kumbaga, na-against hiya, nasurra hiya. Okay? Kung adi, it goes with the flow. It follows the direction of the replication fork. Adi naman na against hiya hiton replication fork. So magkakaproblema. Diba? So, what happens is, kung dinhi continuous, ini nga continuous replication process in a continuous nga strand nga mahihimo is called as the leading strand. Tawag hit niya leading strand. Ini ha, ini nga continuous nga strand. Ini nga continuous nga strand. It nga ini diba inihiya continuous. Ito mahimo niya nga strand is called as the leading strand. Di naman magkakaproblema. Kay every time ma-open inihiya nga fork, every time nga ma-open itong fork, every time nga ma-open hiya, the RNA polymerase will come and will synthesize RNA primer. No? Pag-abot itong primer, kung ta ini nagkamay ada na dida primer dinhi. Primer iton hiya. So iton masunod hiton niya will be ano na to? Oh, wait. So iton masunod hiton niya will be DNA nucleotides. Inopen dari daman an fork. Inopen dari na kahimo da daman yan fork. Kumbaga magiging putol-putol na iniya kay ano? the RNA polymerase will again make the RNA primer. It will again make the RNA primer. Tapos, followed by, okay. So, itong mahinanabo, kay diri naman niya continuous, putol-putol na. So, every time na ma-open itong fork, RNA polymerase will come along the way. So, it will make the RNA primer and will then followed by the DNA primer. The DNA polymerase to synthesize DNA nucleotides. Okay, ma-open the naman fork, RNA will make a primer and will follow and will be followed by the DNA polymerase and so on. Okay, so may nanabo naman din class. Magkakamay ada gap din So, may hiya, may ada gap, hiyang kakamay ada gap. So itong aanhihin din R, so ito na ada iton. So RNA prime. Yeah, RNA primer. Ada ka pula. Primer. Ano yung primer ha? RNA nucleotides. Now, kay discontinuous naman, an iya strand, we call this discontinuous strand in the opposite strand as lagging strand. Tawag niya lagging strand. Okay. So, inihiya, madiro-diretso nga strand, we call it as the leading strand. Adi naman yung discontinuous nga strand, we call it as the lagging strand. The lagging strand. Okay. So, next step is the excision of the RNA primers and the replacement with DNA. Okay. Wala, kung may ada din. The lagging strand is synthesized discontinuously against overall direction of replication. This strand is made in many short segments. It is replicated from the replication fork toward the origin. Now, the short segments in the lagging strand is called as Okazaki fragments. Okay? Inihiya. So, ini nga may ada mga RNA primer. So ito niya may ada mga gap ito niya dida magkakamay ada. Kung baga dalan may magkakamay ada mga buhol-buhol ng mga dalan. So, may ada mga gap. Dire continuous ang pagsemento so nahinabo nagkamay ada mga gaps. So dire man continuous those gaps in the lagging strand are called Okazaki fragments, the series of short segments on the lagging strand. It must be joined together by an enzyme called the DNA ligase. So ito na sunod naman nga step, diba? Nagkamay ada na mga nagkamay ada mga RNA nucleotides dida ano. So the next step is to remove all the RNA primers and the replacement with DNA. Excision of the RNA primers and the replacement with DNA. So, inihiya magkakatatanggal ha inaadto. pantatanggalon because they are not allowed in a DNA molecule actually. So in here, these will be excised, these will be removed, and will then be replaced with DNA nucleotides. Now, there is an enzyme responsible for the excision, and we call it as the DNA polymerase 1. DNA polymerase 1. Pag-remove iton mga RNA primers and replaced with DNA DNA nucleotides, the enzyme responsible for that is DNA polymerase 1. Okay, removal ha. The enzyme responsible for that is DNA polymerase. Yeah, tatanggalon ini, pantatanggalon, iton ini nga mga RNA primer pantatanggalon, it responsible pagtanggal ngayon pag-replace in DNA nucleotides is the DNA polymerase 1. Diba, may ada mga gaps dida, ano? So we go now to the last step. So the last step. Ano ang last step? Sealing of the breaks or the gaps. So di ba kanina may ada mga ini mga buhol-buhol dida, mga buhol-buhol mga. Okay, so this one. Dinhi nga dapit dida ang pag-joinahan primer and the DNA nucleotides. So may adat niya gap. So ito nga gap naman kay the DNA, the cell will not allow to have a segmented DNA. It will not allow to have a fragmented DNA. So itong bubuhaton nitong cell, it will again seek an enzyme. It will seek the help of an enzyme that will seal the gap. Kumbaga dalan an mga luho-luho bubutangan niyan mga espalto para diretso itong dalan. The enzyme responsible for that is DNA ligase. Okay, so DNA ligase. DNA polymerase 1, iyan responsible pagtanggal han RNA primer, tapos pagliwan han DNA nucleotides. Ang mga putol-putol naman, idudugtong iton hiya with an enzyme called the DNA ligase para continuous na an lagging strand. Okay, now, I will let you see a video clip for this. Okay. Ngay, wait lang. Annotation. Can you see, class? Nakikita niyo yung video?
No.
Dari niya nakikita. Okay, anay ha?
Direct po.
Anay. New share. Ito na, okay na. Nakikita na niyo.
Yes.
Yes po. Yes, ma'am.
Okay. Okay na?
Yes.
Po, ma'am.
Okay. Do you want me to repeat this, class? Hello? Do you want me to repeat? Hello?
Okay.
Yes, ma'am. Yes po.
Ma'am.
Okay, so after replication, how many DNA strands will be made? Or how many DNA molecules will be made?
4, 2,
1, 2, 3, 4.
2,
2. Who says 2?
Me.
Who says 3?
Me.
Who says 4? Okay. Only 2 DNA molecules will be made. Duhala. Okay. This one will become a template in the making of the new strand. Okay, wait. Daman hiya, this will become a template in the making of another strand. Okay, so ini, makakahimuhin usa nga DNA, and this is another DNA. Now, the DNA strands that will be made after replication is said to be semi-conservative. Okay? Semi-conservative DNA. So, mering nga ni semi-conservative DNA molecule, it means that one strand is old. So, this is the old strand, and this one is the new strand. This is the new strand, while this is the old strand. Nakuha niyo, di ba? Yan, naging template yan, paghimuhan new strand. Okay, in other words, a semi-conservative DNA molecule is basically made up of an old strand and a new strand. Nakuha? Nakuha niyo?
yes.
Yes, ma'am.
Okay, so ito makakahimo again after replication. It will be able to make 2 semi-conservative DNA molecules. So in a semi-conservative DNA molecule, one is an old strand and the other is a new strand. Okay, another semi-conservative. So this is the new strand, while this is an old DNA strand. Okay? Okay, look at this. The new DNA consists of one parental and one new strand. So this is, okay. So in here, ade. Di naman here, ade. So ade and bago, ade and bago. So this makes or one semi-conservative DNA molecule, another semi-conservative DNA molecule. DNA damage and repair. Chemicals and ultraviolet radiation damage the DNA in our body cells. Cells must be continuously repair damaged DNA. Excision repair occurs when any of over 50 repair enzymes remove damaged parts of DNA. DNA polymerase and DNA ligase replace and bond the new nucleotides together. Okay, now another fact about replication. The speed of DNA replication is 3,000 nucleotides per minute in human. Diba madagmit? 3,000 nucleotides in human. But it is many times faster in bacteria. 30,000 nucleotides are made per minute in an Escherichia coli bacteria. Okay? Asya nga madagmit hira magdamo because of this speed of DNA replication. Now, the accuracy of DNA replication is very precise, almost perfect, meaning very accurate. It is not 100% accurate. It is 1:1. Hala, pera na tiya. Billion, trillion, peran hiya. 1
billion.
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 Maaram ha.
Billion.
1:1 billion nucleotides. So for every 1 billion nucleotides, there is 1 error. In other words, replication of DNA is not 100% accurate. It is very precise, but not 100% accurate. It is because of this small or minimal percentage of error that mutation occurs. Okay? Kay kung diri ini, kung waray niya maging error, meaning diri itong organism ma-mutate and there will be no variation of organisms. God is good. Diri la agsob iton error kay that the cell will not allow to have an erroneous DNA. Kay sakit liwat, mamamatay liwat iton organism. But the cell has the ability to mutate because of this error. Okay? So organisms vary because of this. Okay, hala, sige daw. What would be the complementary DNA strand for the following DNA sequence? We will answer. I will be calling anybody from section Santol who will volunteer. Who will volunteer from section Santol? Any volunteer from section Santol? Plus points, section Santol, who will volunteer? Leana, Gura. Do you want to answer? From section Santol, Yes, Amos, Hannah, thank you. Using your computer, please. Are you using the annotation on top? Use the annotation on top. Just use text. Use text para mas maupay pagkitaan. Okay, sige. Write your answer. Write your answer directly on the screen. Amos. Amos Hana. Na adila adi text na itong gamita Hana. Inilahiya ini. Nga di dahil itong annotation magamit ka. Makita ka dida T, letter T. Text. Click that one. Sige, Hana. Okay, Hyacinth. Just use the text annotation. The one on top. Di kami nakita team answer. Hana, Hyacinth. So, another
Ano po
from...
ito?
Yes. Yes, Hyacinth.
Pagbutang? Pagbutang,
Oo.
ma'am.
Opo, oo.
Then po.
Di dala itong screen, di dala screen. Just use text annotation. Or pwede, bisan ano nila, basta sige, just write your answer
Dala
above.
chat box, ma'am. Chat box na lang.
Chat box. Ba, karoy ako makita na itong tanan din he. Hindi na lang itong screen mismo. Okay la, did it screen?
Wait, ma'am.
GCA. And then C A T A
Oo, no. Wait lang.
tapos
C.
where is your C? Okay, next.
Number 5. 5.
Okay, number 5. So that is number 5. Is the answer correct, class? Is the answer correct?
Yes.
Yes.
Okay, so the answer is correct. Okay, so if in one strand, 5' CGT80G 3', so in the opposite strand will be 3'. Dapat may ada prime dida, nabagis prime. So G C A T A G C and 5. So the answer is correct. Thank you for that, Hyacinth. So next, we go to the summary. So here is now the summary. So in the unwinding, opposite to the steps are the enzymes involved. So we have helicase, the SSB, and the gyrase for the unwinding process. For the priming, for step 2, the enzymes responsible, or the enzyme responsible is RNA polymerase, we also call as RNA primase. Elongation is the DNA polymerase 3, excision, the DNA polymerase 1, and exonuclease. The exonuclease is actually responsible for the excision of the nucleotides and then replaced by the DNA nucleotides or the DNA bases by the DNA polymerase 1. The sealing of the gaps is made possible by DNA ligase. Dugang ko la didi ha. Anay. Just include, okay. Exonuclease. Okay, please copy that one. Are you copying now?
Yes, ma'am.
I will just post the schedule. The next discussion will be protein synthesis. Protein synthesis. Now, para diri halaba itong coverage, I want to give a summative test for this. Or hulton naton itkuan. Hold to nala. You decide. Humanong titan protein synthesis before I give the summative test. Ha? Hay mas maupay. Mahatag yung summative test after the coverage will be nucleic acids and DNA replication, or summative test wherein the coverage will be nucleic acids, replication, and protein synthesis. Manong tanalanay ano? Lugod. Class.
Okay.
So, what will be your decision, class? Manong talaanay and module 4. Lesson 1 and lesson 2 will be the coverage for the summative test. Okay la?
Yes, ma'am. For me.
Okay. Okay, very good. So we'll have it on. We'll have our next discussion on when? When do you wish to have it?
Monday?
Tomorrow, Monday.
Friday?
Friday, Monday.
Monday?
Monday?
Monday.
Monday.
Okay lah iyo, Monday.
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 So pagka Monday, kung Monday, we will have the summative test on Tuesday. Ano?
Sure, ma'am. I'm alright with that.
Okay, so that ends DNA replication. I hope you learned something today. Do you want me to upload this in the Google Classroom?
Yes, please.
Yes, ma'am.
Yes,
Okay.
Yes,
Wait na lang ha. I'll upload this after the class. Yan na to. Okay, so see you on Monday again. See you on Monday. So those who were present today will be given additional points during the summative test. I want you to be present again during the discussion on protein synthesis on Monday. I hope you learned something today. Goodbye, class.
Goodbye, ma'am.
Goodbye, ma'am. Thank you.
Okay.
Thank you po.
Okay, thank you. You're welcome. Anay, pwede Can you turn on the camera? Can you turn on the camera? For the last checking of attendance. 4 people entered the waiting room. Nakainhinin niya. Okay. So 1, 2, 3, smile. So next, we got the page 2. 1, 2, 3, smile. Okay, so goodbye, class.
Bye.
Goodbye, ma'am. Goodbye, ma'am.